Right, so a locus is a set of points that obey a set condition. Okay? Now mainly you'll be looking at the set of points that follow a path. Okay? In other words, when we're graphing things or when a set of points follow a line or follows a certain path, for example a parabola. Okay, we'll be looking at the conditions of that. Everyone got the notes? Okay, so I have penciled that I will do order theory in 4, maybe 5 lessons. Alright, so if I can get all the theory done, and then I'll allow some time next term, the couple weeks I'm not here, okay, for you guys to get some work done on that. Alright, so we have a set of points that obey a certain condition, okay, which will often trace out a path for you guys. So, examples, let's describe the following situation. So we describe the locus. Alright, so A, so what is the locus of a cricket ball? Being thrown to the wicketkeeper. How would you describe the path? Hey? An arc? What would we call it mathematically? Okay, so what's the path of that? Parabola, isn't it? Yeah? Alright, so the locus of a cricket ball. Okay, so if you picture it being sent out to the from the fielder, you'll throw it in that sort of motion, wouldn't he? Hey?
This is simple. No.
Wouldn't he? What?
Bounces along the way.
It could, alright, but when it bounces, what happens after that, Amanda?
It still does a parabola.
Unless it hits a small rock and it just rolls.
They are, hey, sorry?
Unless it hits a small rock, it just rolls.
Once we obviously get to a point where it's not bouncing upwards anymore. Alright, we will just roll. Alright, so we have a parabola, alright, and we'll talk about this in the future, but a concave down parabola. Alright, example B, what does it say? Alright, so what would we describe that path? How would we describe it? Okay, going straight up, vertically up. Okay, so vertically up. Okay, and if we were to write an equation using variables, what could I write? Okay. Alright, so we consider the number plane. Alright, and we've got a point where it's going up. Okay, some point on that. Alright, so this could be the variable C, for example. Alright, we cut which axis? X or Y? X, so we cut the x-axis at C. So the equation supposedly will be represented by x equals C. Alright, where C is a, what would I call the next word? Okay. Okay, constant. Alright, C. A child going down a slide with a constant gradient. How would you describe the path? Alright. Okay, parabola.
It doesn't curve, it's straight line.
Constant gradient. Okay, so you got a slide, some sort there. Okay, you got some happy little kid up the top, about to go down. Alright, we're going down with a constant gradient. So we have a, what?
Yeah, you hit the bottom.
Alright, so we have a straight line in the form, what? Go back to last year's work. How do I represent an equation in a straight line?
A straight line equation.
Yeah? Y equals?
X plus
That's one example. Or how do I represent a general straight line?
X minus X1.
No.
X
No.
plus A. B. And X plus B, that's him.
Can I
I remember that.
slap you across the head because
Go ahead.
your work from the last year is built into what you're doing this year and year 9 as well, of course. Okay. We'll look at more of that when you do coordinate geometry when I'm not here. Okay. Now D. The dog. Tied up to a corkscrew on the ground. So in my yard I've got a corkscrew tied on the ground. Dog's on a leash. Because if the dog's not on the leash, he comes and destroys things. And, okay, so he's on a corkscrew on the ground, so if we consider a top view of it, okay, he's got a lead on that, okay, there's the dogs, there's the corkscrew, what's the path? Okay, could be a circle, couldn't it? Okay, however, we're not just restricted to the circumference of the circle, aren't we? Alright, because the dog can go anywhere inside of that. So how could I represent that using the equation?
The area of the circle.
You're on the right track, yes. Anyone know the equation for a circle?
Y squared plus X squared equals Y squared. X squared.
Alright, so x squared plus y squared, which is the radius squared, okay, and you will cover that more when we do functional graphs in our next term. Okay, we're just getting ideas out there. Okay, where the corkscrew is at origin and the lead has radius R. Okay, so we're just considering the paths that get traced out. Alright, so if I were to open the window here, alright, then we want to look at this, this locking mechanism. So we want to consider the path that the locking mechanism goes as the function the window opens. Okay? As it slides. Not the turning bit there, but as it slides. Okay, we have a what? Horizontal displacement. Okay, so it goes in a horizontal direction. Okay, it doesn't go up or down at all. Okay, the whole mechanism itself, not the turning bit. Okay, but it goes in a horizontal direction back and forth wherever I have the window. Okay, what about a doorknob as you are opening the door? Goes on an arc, doesn't it? Okay, or wherever the wall and the door closing allows it to go. Typically a quarter circle. Okay, if you think about it. Alright, open and close in that direction there. Okay. What about someone jumping off a diving board into the water? Yeah, okay, so you're not just considering then jumping straight down, okay, but in some point of that, the traced out a path of a parabola up the very top, and then, yes, obviously straight down from that. Okay, so this is what this topic's about, okay, thinking about how a point follows a certain condition. Right, now we're looking at an equation of a locus. So, any questions on this before I move on? Alright, so equations of a locus, 11.2. Right, so we're now looking at a point, the locus of a point, which we will notate as a capital P, X and Y, so we've got a coordinate, which follows, on the Cartesian plane, that traces out a path that we can determine the equation of. So let's look at some examples. A. Find the locus of a point which moves so that it is always 3 units above the x-axis. Alright. Good. Alright, so let's draw it first. So we've got a locus, so we've got a point P, which has coordinates x and y. Okay, and this point moves so that it is always 3 units above the x-axis. Okay, so this point will move in that direction. So when you form those points, those infinite points that move, it'll form a straight line. Okay, so you consider it then as a line. Okay, we are always 3 units. So the locus, okay, is going to be the equation of the line with the intersection of the y-axis at 3. So the point will follow the path defined by the equation y equals 3. Alright, B. Find the locus of a point which moves so that it is always less... hang on. Can we go back up to here? What's the problem here? Yeah, okay, so what would I replace on the equal sign? Okay. Greater than, less than. Well, anywhere inside of that circle, okay? So we form that circle, okay? The dog can be anywhere inside that circle. Alright, not on the boundary, not just on the boundary, sorry, we can be on the boundary, that's why we've got the equal part of the inequality as well. Okay, but it can be anywhere inside that boundary. Alright, so the locus would be the region, and we'll talk about that more in the future as well. Okay, this was supposed to be done after, but I'm doing something more difficult now so that you can continue to do something a bit more straightforward to finish your term. Okay, so we'll talk about regions when we do it in functional congress. Right, so get back to here, part B. So we all find the locus of the point which moves at always less than 1 unit from the y-axis. Alright, so here's a quick sketch. Alright, this is my x and y. So we need the point P. So we've got a point P somewhere. Okay, and we want to now consider how the point P moves so that it is always less than 1 unit from the y-axis. Okay, so which direction would I move now?
X is greater than or equal to -1.
No, x, 1 is greater than x is less than 1.
Almost. Right, so we get a vertical line, okay, at the point 1, that is always less than 1 unit from the y-axis, okay, and we also can have it on the other side as well, okay, so we've got the distance, the displacement of 1 unit, so we're going into the negative direction of the line x equals 0, okay, and then we can have always less than 1 point. So what we are now defining is that region that gets formed between those 2 lines. It can be, that point can be anywhere in that general region. Okay, so -1, which is less than, okay, cut the x-axis, that's going to be the equation of my lines there. So in other words, x is greater than -1, okay, because there's a bigger point here, and you also have x is less than 1. Okay, from those 2, alright, so the value for x has to be between -1 and 1, not including those endpoints. Okay, so the equation of the point P can be anywhere in that region. Okay, so the point P could be here, the point P could be here, the point P could be there, okay? The point P cannot be out of that because it does not define correctly the path that it's following.
Yeah, but I mean like less than or equal to. No, it doesn't say equal to.
It's less than.
So it's always
Strictly less than 1 unit away from the y-axis. Okay, the idea will get clearer as we do more examples. Okay. Alright, C. Find the locus of the point which moves so that its distance from the x-axis is always twice its distance from the y-axis. Good. Excellent. Okay, so you consider point P over here, x comma y. Alright, so that means the distance from the x-axis is double the distance from the y-axis. Okay, so if the distance, the point P moves up here, okay, and let's say that distance is 4, okay, so it has to be there, that means this point, this distance there has to be 2. Alright, so the distance from the x-axis is double the distance from the y-axis. Alright, can everyone see that the line, the path is going to be traced out, is going to be this line here? Yep, and then we need to simply state the equation of that line. Okay, so y equals to x. Okay, so the value for y is double the value for x. Alright, so where x is 2, alright, so when the distance, between the x-axis and the line is 2, alright, so y has to be double that to suit the equation. Okay, 2 times 1 is just 2. Right. D. Find the locus of set of points which are such that their distance from the x-axis is always 3 units more than the distance from the y-axis. Alright, so pick a point P so that its distance from the x-axis is always 3 units more than the distance from the y-axis.
X equals y plus 3?
Other way around.
Y 3.
Yeah, 3 units more. Okay? So, if I have this distance here is 1, alright, so 3 more, so that should be 4. Okay, so 3 units more. Alright, if I have the point over here P, and that distance here is 2, alright, so the distance from the x-axis is 3 units more. Okay, so that means this overall distance here is going to be 5. Okay, of course at the origin, we've got 0 and 3. Alright, so the distance is nothing, so 3 more than nothing is 3. Okay, so that means the intercept of the y-axis is going to be at 3, and then the line is going to do something like this.
That was a really straight line.
What's about to say? So y equals x plus 3 would be defining all those points that follows that path there. Okay, are we somewhat getting what's going on? Alright, like I said, it is new, it's a new way of thinking as well, and it will take some time to become clearer, but we will get there as we get through the topic. Alright, so a point P, x comma y, so the coordinate moves so that it's always equidistant from the point A, minus 1, 6, and B, 3, 2. Let's find the equation of that path. So, first thing I need you to do is sketch those 2 points. E. So we have the point A, which is minus 1, 6. It's about here somewhere. The point B, which is 3, 2. Bless you. We need to find the point P so that it moves, so it's always equidistant from the point A and B. Find the equation. Okay, so in other words, if this was the point P, okay, that means the distance here and here are equal. Okay? So, following that, the point P, if it was down here, alright, and I'll join PB and PA, they are also equidistant. Alright, so if I go way out here, I'll join PB and PA, that was a terrible one. Alright, does that mean these two distances are also equal? Alright, can everyone see the path that's going to trace out? Not the actual equation, but the path. Alright, so we're going to go through something like that. So we need to find the equation of that line. Any ideas on how I'm going to do it? So? Yep, we're going to do that. Alright, so the distance PA must equal the distance PB. Correct? Alright, now going back to last year, and I have been told you have done this. Alright? Yep, and that's what you're doing in your coordinate geometry. Okay?
Yeah.
So you have all seen this before.
Yeah.
Good. Right, so we use that. Alright, so that means that we need to calculate the distance PA and the distance PB. Alright? Using my variable P, which is x, y. Now, the first thing I'm going to do is write the following. Both sides are going to get squared. Right? The reason for that is because we're going to remove this root symbol here. Okay? So we're not dealing with the square root. Alright, so the point P has the coordinate x, y. The point A has the coordinate -1, 6. And the point B has the coordinate 3, 2. And that is what you're going to substitute into those two equations there. Alright, so the point P, we can call this x2, y2 for the point P. Alright, and then the A and B on the respective side can be my x1 and y1. Okay? Alright, so using this formula, so x2, which is simply x, so we're doing PA squared, which is PB squared. Alright, so just rewriting this line so I can just follow it a bit more structurally underneath. Right, so x2, so in this formula, so without the square root, because we've squared both sides here, so essentially we are putting this in place for each of those, right? And then when we square them, we remove the square root symbol. Okay, so what we're doing is x2 take away x1 squared plus y2 take away y1 squared is going to be x2 take away x1 squared plus y2 take away y1 squared. Alright, so there's your formula. Now we need to substitute into those. Alright, because we're calculating the distance PA and the distance PB, and we are told that they're equidistant, so the equation is formed with the equal sign there, and now we substitute. Right, so x2, which is x. x1, so this left-hand side is PA, so x1 is minus 1. Take away a negative 1 squared. Okay, y2 is y. Take away, and y1 is 6. Which is equal. So, PB, so we've got P and B. So P is x2, y2. So we've got x and y. And then x1, y1 is 3 and 2 respectively. So, x take away x1, which is 3 for the point B. And then y2, which is just y. Take away y1, which is 2. And we square that. Right, let's tidy up a bit. So x plus 1 all squared plus y take away 6 all squared, which is x take away 3 all squared plus y take away 2 all squared. So all I've done here is just change those two negatives to a positive. And now we need to do what? Expand it. Right, everyone expanding those full terms? We of course know how to remember do it. We all remember how to do it. X squared plus 2x plus 1. Y squared take away 12y plus 36. So expanding each of those. X squared take away 6x plus 9 plus y squared take away 4y plus 4. Okay, so now that we've expanded, we're now going to simplify. Right, so watching. So I have a positive x squared and a positive x squared on either side of the equal sign. Okay, so they will cancel. Because if I move one of them over to the other side, change the sign, I'll have an x squared take away x squared, or a negative x squared plus x squared, which is 0. Alright, again, we've got y squared and y squared. It's my only squared terms of y. Alright, so they'll cancel. So now I have linear constants, okay, in terms of there are no squared terms. Alright, so we have now the following. We've got 2x, negative 12y, 1, 36. So 2x take away 12y plus 37, so tidying up the left-hand side, which equals negative 6x take away 4y, 9 plus 4, which is 13. Have you done equation of a line in general form? Yep, so let's put it in that format then. Alright, so we need x positive, so I've got negative 6x. If I move it over the other side, it becomes positive. So 8x. Okay, and then a negative 4y. I'm going to move over to that side as well. So negative 4y, when it's moved to the other side of the equal sign, becomes a positive. You've got negative 12 plus 4. So you get minus, sorry. 8x take away 8y. And then a positive 37. On this side, you need to bring this over to that side. So everything's on the same side of the equal sign. So 37 take away 13 is a positive 24 equals 0. Okay. Right, each of my 3 terms on the left hand side has a factor of 8. Okay, so I'll now bring the 8 over the other side by dividing. So 0 divided by 8 is 0. Okay, now put it in the format that you're used to. I've got the negative y. I want to make it positive. I'll move it over to the other side. X plus 3 is equal to y. So y is x plus 3.
Whoa. We did that.
And that is the equation of that line.
Well,
Okay, so what this means is that line y equals x plus 3. So we've got the line doing that. Okay, that line will always be the centre point of the 2 coordinates. So we've got B, which is 3, 2, and A, which is negative 1, 6, something like that. Okay, so that line will go through those 2 points, and the distance between any point on that line to those 2 points on the plane will always be equidistant with that equation. How are we feeling? I've lost you?
Oh, jeez. No, we have. We really
We
have.
have, but
You guys are as bad at this point. Holy crap.
what?
Did everyone understand how that worked?
Yes.
So what you guys are just struggling to comprehend is how that became that. Is that correct?
I got all of it, like it's all
Yeah.
logical.
It's just a lot
I
of
just
it.
hate that I have to go through all that process.
So,
I did go step by step, so once you are more familiar with these styles of questions, you'll be able to do less working. Okay? Yeah, but obviously, like I said, it is new, a new way of thinking, a new way of working as well. Okay, but the math works out. Okay,
how,
it actually works.
how long did it take that U-turn student to get the phone number thing?
How long?
Yeah.
I found out he wasn't correct.
Oh, okay.
Yeah, but he did have the same answer as I did, but I forgot to consider something very important, so I haven't finished my answer yet. We've got time for one more. See if it makes a bit more sense with the last example.
Wait, time for a short one or one like that?
Hey?
You want to know if it's short or long like the other one?
Well,
Look at the
Find out what the question
question on your
says.
little book.
let me see.
Find out what the question says.
It was, that looks...
Remember the time we had 10 equations? Yeah.
Oh, so you're just proving that that is right.
Right, so the point P moves, so that's F now. F. So the reason I'm doing this now because it's start of term 3, there is an extension topic of this.
Rectum. Rectum. It says rectum. What's a rectum in terms of math?
Latest rectum.
Lattice vector, we'll
Lattice
talk about that in future. Alright, so the point P, xy, moves to the distance from PA, which is A15, always twice the distance PB from the point that. We need to show that locus. Right, let's draw it first. Right, so we've got a point P, distance from point A, which is 1, 5. Right, so that's A. It's always twice the distance PB from the point B, which is 4, something like that. One 5, 4 minus 1. So the point P moves at a distance PA from the point A is always twice the distance PB. Alright, so let's put a point P, which is X, Y. Okay, so in other words, if this is 2 units long, the distance from PA means that the distance between PB is 1 unit long. Okay, so we need to now find another point, label another point, sorry. And the distance PA, let's say that was 6 units. Alright, and then it's not very accurate. Alright, but how long, if PA was 6 units long, how long would PB be? 3. Okay. So we need to find the equation line that suits those points. So the question starts off the same. Alright, so P, the ratio of the distance. Okay, so we need to write the ratio first. So the ratio of PA, which is double the length of PB, so the ratio will be 2 to 1. Okay, let's write it in fraction form. The PA over PB, which equals 2 over 1. The left hand side of the ratio goes on top, the right hand side goes on the bottom. And now, because I've got denominators, I'm going to cross multiply. So, PA is going to be 2 lots of PB. Okay, which makes sense because this distance here is always double this distance here. Alright, and that is how you set it up. Okay, it's not 2PA equal to PB, it's the other way around. Alright. So, we need to use that distance formula again, and we're going to square it so that we eliminate that square root. Alright, so that means that your PA squared, now this is an interval, it is not A squared multiplied by P. Okay, in this context it is an interval, so you are squaring that interval length. Alright, in other words, removing that third. So PA squared, which is 4, 2 squared, which is 4, and then PB squared, the length of that interval squared. Alright, formula, x2 take away x1 squared plus y2 take away y1 squared is equal to 4 lots of x2 take away x1 squared plus y2 take away y1 squared. Alright, so let's call the capital Right, is everyone following to that point? looks like you are, Amanda. Okay, so you have seen the distance formula for your coordinate geometry. So I'm basically applying it here. Yep. There's not very many numbers there at the moment. Alright, so we have 3 points. So we've got the point P, we've got the point A, which is 1, 5, and the point B, which is 4, minus 1. Okay, and that's what's getting substituted into your formula. So, my point P will be my x2, y2 for both sides, because P is in both sides. Alright, and then my remaining 2 for their respective sides are x1 and y1. Okay, so let's substitute that into the equation there. And then tidy it up and show that it equals what we got in our notes there. Alright, so x take away, the x take away on the left hand side is a, so x take away 1 squared, okay, y2 take away y1, so we've got y take away 5 squared is equal to 4 lots of everything that we're about to do here. So, we again got the point P, so we've got x and y for x2 and y2, and we now have B, so we've got 4 and negative 1 for your x1 and y1 respectively. So, x take away 4 squared, and then you have a y take away. That's happened. I wonder how that will affect the recording. Alright, so everyone's understanding up to this point where the variables came in, the numbers came in. Alright, so expand, simplify, and show that it's equal to x squared take away 10x plus y squared plus 6y plus 14 equals 0. Alright, so expand everything first. So it looks long, however it's just repetition, most of it, an algebra skill, which you need to be good at to be successful in this topic and this course. Okay, this is algebra. Expand and simplify.
No, we're proving that.
Yeah, but there's no 4xy in there. I mean 4x squared.
See? Will let Mr. Lee teach?
Because there's an x squared and a 4x squared.
Look, I'm just happy with x squared.
There's an x squared and y squared there.
Oh yeah, we haven't.
You're not gonna
You gotta get the other side first.
Yeah, it's not.
Hey?
It'd be 3xy. It's xy. X squared. 4x squared there, which is gonna make it 3x squared.
Yeah.
Yeah, that's.
We'll
not
leave
x
him
squared.
teach.
Are you
Because
gonna
he's
factor
probably-
it out or something?
Yeah, probably.
Gonna have to,
There
aren't
we
I?
go.
Glad you're thinking. So we've got 16 plus 1, which is 17, 40 and 24. So I've added the 16 and the 1 to get 17, then 4 lots of 17, not 64. 10, 40 and people need to go, or have me keep going and finish it?
Keep going.
Keep going.
Might as well, it won't take
Yep.
that long, will it?
Alright. So, I want to keep things positive, so I'm going to move everything on the left-hand side over to the right, because I've got the 4x squared, which is positive, and then move the x squared over, becomes a negative x squared.
So,
Alright, so this becomes a negative x squared. The y squared will be negative y squared.
so
The negative 2x, move it over the other side, plus 2x. Negative 10y, plus 10y. See how I'm lining everything up? Make it easier. Right, then 54, and then a negative 26 to undo the positive 26 on the left-hand side. Right, so the left-hand side equals 0 because we moved everything. 3x squared, take away 30x, plus 3y squared, plus 18y, 26, 18, 28.
Look at that.
I need to divide the half.
Alright, so 3 lots of x squared, take away 10x, plus y squared, plus 6y. Oh, 28 doesn't go on 3.
Oh no.
14.
We did something wrong.
Yeah.
Really?
Yeah, it's meant to be 60.
Alright, change that. 68. Take away 26. 28. That's 48, correct? 42.
that was 13.
30, 33, 36, 39, 42, plus 16. Hurrah.
Now we can go.
Be free.
Wait, plus 16.
Alright, so therefore, x squared take away 10x plus y squared plus 6y plus 16 is equal to 0.
That was pretty lucky.
Alright, so we'll finish those examples up tomorrow.
No, I'll try-
Thank you for your patience.